In this video, we'll be proving this trigonometric identity. The first step here is to rewrite tangent and cotangent in terms of sine and cosine. So tangent theta is sine theta over cosine theta, and cotangent theta is cosine theta over sine theta. Now, I'm going to factor out a sine theta from the top and then a cosine theta on the bottom. So on the top, if I remove a sine theta here, I'm left with sine theta minus 1 over cosine theta. And on the bottom, if I remove a cosine factor, I'm left with cosine theta minus 1 over sine theta. At this point, I don't like the cosine and the sine in the denominator, so I'm going to multiply the top numerator by cosine over cosine, and the bottom, the denominator, with sine over sine. And the idea is to get rid of these cosines and sines. Okay, now I'm going to have this cosine theta distribute whatever's inside the parentheses. And then this cosine theta on the bottom is going to go underneath the numerator. And then same thing with sine theta. Sine theta is going to multiply cosine theta and negative 1 over sine theta. And then this bottom sine theta is going to go underneath here. So sine theta, cosine theta. And then when I multiply 1 over cosine theta with cosine theta, I just get 1 here. And then the cosine theta, we said, is going to go on the bottom. Same thing with sine. Sine times cosine. And then sine times 1 over sine is just 1. And then the sine is going to go underneath here. Now at this point, you can think of this as dividing two fractions. And whenever you divide two fractions, you multiply the reciprocal. So we're going to leave the top fraction alone. And then the bottom fraction, we're going to flip. So sine is going to be now the numerator. And then cosine times sine cosine minus 1 is the denominator. The nice thing is the sine cosine theta minus 1, sine cosine theta minus 1, those go away. And so what you're left with is sine times sine over cosine times cosine. So that simplifies to sine squared over cosine squared, which is tangent squared. And that's exactly what we wanted to prove.